So as you saw in the video, when you put iron filings down around a magnet, you're going to be able to see the magnetic field, which is basically just the region around the magnet where there is that force exerted. You'll see more at the poles because that is where the most magnetic field is, the strongest part of the field. And then in the middle, you'll have a little less. So here we have some pictures of what the magnetic field looks like when we've got two poles interacting. On this first one on the left, we have North Pole interacting with North Pole, and you can see the magnetic field through these iron filings. Those magnetic fields for each part of the magnet are trying to basically push off of each other. You can't bring them together, so these would be repelling. In this middle picture, we've got south, we've got north, and those field lines are interacting with each other in a way where north is coming out and it's going into the south, and that is causing these to want to be pulled together. So we said that they come out from one pole, curve around, and then they go back into the other pole, away from the north, and they go in at the south. The arrow on those field lines shows what direction that magnetic field line is moving. The distance between those magnetic field lines tells us the strength of the magnetic field. If they are widely spaced, meaning you've got big areas in between them, kind of like here in the middle of this magnet in the picture, you can tell that this is where the magnet is weaker. If you look here at the poles, you can see a lot more lines and they're much closer together. That tells us that the poles have a stronger magnetic field than the middle of the magnet. Magnets have three properties. They attract iron and anything that contains iron. They also will attract and repel other magnets. And if you were to suspend it from the ceiling, you would always have the north end pointing north. That's how we have used magnets to develop compasses. Now, because that magnet, when you hang it freely and let it swing freely, lines up with magnetic north and south on the earth, we know that the earth is kind of like a giant magnet. It has a magnetic field. Something that's interesting you can see in this picture off to the right here is that magnetic north has not always been in the same place. It's actually moving more north over the years. And we're going to get into why the earth has a magnetic field when we talk about the layers of the earth. But basically, there are things going on with the outer core and the inner core, convection currents and things that they think are causing our magnetic field here on the earth. The magnetic field is very important for us that live on the earth. Now, we can tell that the earth has a magnetic field, and we can tell that there have been changes in the direction of our magnetic field. Magnetic north hasn't always been magnetic north. Also, the strength of our magnetic field has changed a lot over time, and we tell this by looking at the ocean floor, right along what's called the mid-ocean ridge, and we'll get into all of this when we talk about earth science. But basically, scientists have found that the minerals, the iron-containing minerals that are in the ocean rock on the bottom of the ocean, the basalt on the ocean floor, they've been lined up in a certain direction with magnetic north and south. And then about every million years, those pieces of mineral that are in those rocks have flipped to the other way. So we basically get these stripes along the ocean floor. When these rocks formed, the rock was aligned, those minerals were aligned one direction. And then more formed about a million years later, and those minerals are now aligned the other way in the newly formed rock, telling us that the magnetic field has completely reversed many times in the past. Now, the last time we had a magnetic field flip was about 780,000 years ago. So we will be heading into another one eventually, not anytime soon, but eventually we will have that flip again. We aren't 100% sure of what will happen when that occurs, but it's happened in the past, and it, of course, will happen again in the future. Now, that magnetic north and south for the earth helps us tell direction. We use things like compasses to help us know which direction we're moving around on the earth, and that is thanks to a magnetized needle that is able to spin freely inside the casing of the compass, and that always helps us to determine where north and south are.